Well, good morning. I don't know if any of you are there yet. I'm running sort of ragged right now. My last class had so many questions that ate up the full 15 minutes I had in between classes. So that's why I'm a bit late getting started now. I don't know exactly what time it is. We're 10:08. Sorry about that. But I just sent the announcement, the invite, with the code on it, so hopefully people will be adding now. Is anyone there yet? Not yet. All right. Well, I guess what I have to do is go on and get started. Now, here's a problem, and you may remember this from before if you listened to the last class. We're in section 5.2, but they only had one PowerPoint example in 5.2, so we're doing the other PowerPoint examples, but I'm using the 5.3 PowerPoints because there weren't any more PowerPoints in 5.2. So I'm going to have to find one that has a lot of white space. That does, but let's see if we can find anything. Here's one. Let's use this slide here to do my examples, and I think we're in chapter 5, analytic trigonometry, section 5.2, verifying trigonometric identities, and we're at the top of page 358. I assume nobody's here yet, so I will just keep going until someone shows up. All right. Now this is something. Oh, here's somebody. TE34. Do I have a clue of who that is? Oh, that looks like Thomas E. That's where I got it. Okay. Okay. Can you see the screen and hear me? Okay, and you see the screen says example 1?
Yes, sir, I can see it.
All right, good. Is anyone else out there? Just Thomas? Okay.
Yeah, it looks like there's just us two right now.
Okay. Well, as others come on, if you see that they've come on and I'm not paying attention, please let me know. Okay?
Okay.
All right. So I'll backtrack a little bit of what I just said. We're in chapter 5, analytic trigonometry, section 5.2, verifying trigonometric identities. And we're at the top of page 358. Now, you'll not find this as example 1. This is in 5.3. In 5.2, there were only one example, and then that was the only PowerPoints that they had. So I went on to 5.3 because that's where we'll be picking up when we finish the examples in 5.2. Now, I put out the information, but it was sort of late on Tuesday that we did have class. But since we had missed class twice earlier in the month, I couldn't afford to miss another day. So you'll have to pick that one up on YouTube videos. I am recording, as you see down here. I'm still recording. I'm still doing everything like we were in class. The only difference is I'm at home and you're at home. Okay, so hopefully the others will be joining too. But I'm still recording, doing all that. Now things do.
It actually took my link a little bit to load up, so that might be what they're trying to do is load up the link and stuff.
And I was late getting it out there because my last class didn't end. I mean, I tried to end it at 9:45, but they kept having question after question after question, and finally it was 10 o'clock before I could get them to shut down, So
it's
then,
just like the real school, huh?
What's that?
It's just like at Lawson when everybody keeps coming up and asking you questions.
It truly is, because you're usually the first one in and they're still up there. This time it was even worse because they were trying to find out what I was going to do about this test and what to do about that and the other thing. So once we get everybody on, let's try to answer those questions early on so we aren't right at the end, because I only have 15 minutes between this one and the next class. So we'll try to go from there.
Alrighty.
All right, so at the top of page 358, Any questions first before we get started?
I don't think so. Oh, actually, I do have one question.
Okay.
So, if we haven't already turned in our research paper, are we just supposed to email it to you now?
Yes. Please email it to me. Now, there is a way you can do it through Blackboard if you'd rather do it that way, but email, I think, is just as good. Now, the dean said I don't want to do everything by email, that'll just fill up my box. But I've still got to do all the same things, copy them and print them and everything else. So I don't see why filling up Blackboard is any better than filling up email, but whatever. So I would say, yeah, just email it to me. And let me also say this. I'll probably say it again after everybody's here. In my guess, my estimation, we are not coming back to campus, whatever, April 6th or whatever they're saying, 5th or 6th, something like that. This pandemic is still on the increase. It is not decreasing. It is not, will still be increasing in 2 weeks, I think. This is just my humble opinion, but I think we'll still be like that. My wife said that UAB and University of Alabama have both said not coming back this term. They're not even holding graduation in the spring. They're having virtual graduation. So I think that the two-year schools will follow their lead. I sure hope so. But even if the school doesn't, the dean called me Monday of this week and said, don't go to campus tomorrow. I said, well, I've got to go to campus tomorrow. I've got to pick up my books. She said, oh, yeah, that's right. You probably do, don't you? So she said, with my health situation, I shouldn't be on campus at all. So even if the school goes back, I bet you they're going to tell me I should stay at home. So my guess is we're going to finish the term like this. So yeah. Now,
but I mean, you already do like the YouTube videos and stuff, so you've got experience with.
What's that again?
Oh, you've already got experience with like the YouTube videos and stuff, so it shouldn't be that hard.
Right. Okay. So we'll see what happens. All right. Any other questions? So test, I'll be. Say again.
I think that was the only question.
Okay. Test, I'll be, when we get to the end of chapter 5, I will be emailing you the test. Okay. I'll do that through Blackboard. You do the test and scan it and email it back. Okay. We'll have to do all our communications that way. If I can figure out how to do it on Blackboard and it's easier, we'll do it on Blackboard. But I think it's just about as easy. Now, wait. This is this new Blackboard Ultra. The old Blackboard was pretty easy to send emails with attachments. I don't know if this new one is. If it's awkward to do so, then we'll do something else. But right now, I'm going to, thanks to the whole group, I'm going it through Blackboard and try to attach emails that way. Is that okay?
Alrighty.
All right. So, top of page 358. Now, this is something I talked about when we were doing some of the examples, earlier examples. Did you get to hear the YouTube video from Tuesday's class?
Tuesday?
What's that?
Is this the one from Tuesday that you're talking
Tuesday, right.
I haven't had a chance to look at it yet.
Right.
But I plan on going
Okay.
looking at it.
When you do that, you'll see me talking about this very same thing. The book calls it rationalizing a denominator, and we certainly do use that when we're dealing with irrational numbers, like square roots and things like that. But in a more general form of saying that, anytime you have an expression such as this, and we talked about this before on that last video, 1 over 1 minus cosine x. Okay. Now that's sort of an awkward form. Why is it awkward? You have a binomial in the denominator. Okay? Those are sort of hard to mess with. If you had a monomial down there, that would be easier to deal with. If you have binomials in numerators, that's usually not too big of an issue. So when you have a form like this, okay, what I call it is multiplying by the conjugate. Now, we talk about complex conjugates, we talk about irrational conjugates, we talk about all sorts of conjugates. Anything can have, anytime you have a binomial, okay, something plus or minus something else, it has a conjugate. What would be the conjugate of that denominator? Any idea?
Would it be sine?
Okay, no. Okay, keep the same thing. 1 plus cosine x.
Okay.
That's it. Okay. Remember, you do that when you're rationalizing denominators. When you're dealing with complex numbers, you do that. You multiply by the conjugate. Because what does that? Well, if you multiply the denominator by it, to keep from changing the problem, you have to multiply the numerator by it as well, right? And here my pen goes again. It started this yesterday and actually died on me in the middle of a thing. And I had to go back. I thought it was completely dead. I had to go back and start over, and then it came back again. Okay. I found if I write a little more slowly, it doesn't do as badly. Okay. So that's the same form as we had before. I just multiplied by 1, right? That's legal in most states, right? So let's see what we get there. Multiply that by 1, you just get 1 plus cosine, I have to write slowly, x. Okay. What does the denominator give us? What?
It cancels it out.
Say again?
It cancels it out, doesn't it?
No, not quite. When you multiply, let's say if you had this, a plus b times a minus b. Going way back in algebra somewhere there. What did that give you? When you multiply?
It's positive a and a negative b.
Okay, it's a squared minus b squared. You can FOIL that and see it, right? A times a is a squared. This would be a minus ab plus ab. That adds a 0. And then minus b squared. So that's what you get anytime you multiply by a conjugate. You get the difference of the squares. And that's why if you had square roots in there, you lose the square roots. Okay? If you had irrational numbers, complex numbers like i's in there, you lose the i's. Okay? That's why it's such a handy tool. Okay? So what do you get here?
Well, 1 would stay the same.
1 stays the same.
And then would it be cos of x squared?
Yes, minus cosine squared x. Perfect. Now the question is, what is 1 minus cosine squared x? Whoa. Anytime you see a square in a trig expression, it's only squares in there, think Pythagorean identities. Ring a bell? Okay. I'm going to have to talk with your trig teacher. Okay. All right. Here's the main. Always remember this Pythagorean identity. I've just lost my pen. Let's see if I get, yeah, there, I got it back. Sine squared x, can you finish it for me? Plus cosine squared x is always, always, always equal to 1. Okay. If you go back to the very beginning of 5.1, have you got your book in front of you?
No.
No, okay, well, that's all right. If you go back to beginning of 5.1 on that first page, page 348, you'll see all those fundamental identities with the Pythagorean identities right about the middle of that box. You go back to chapter.
Did you say it was?
Say again?
What page number was it?
348 is one page number. If you go back in chapter 4, I bet you'll find that same set of identities maybe 2 or 3 times on various pages in chapter 4. When they talked about the unit circle, and they talked about right triangle trig. Everywhere they show these identities, That's one to always remember. Okay? It's always true. Sine squared plus cosine squared is always equal to 1. Now, what we have here is a 1 minus cosine squared. So what we can do is subtract a cosine squared from both sides of this one. Okay? And this goes away, and what does that tell you? Sine squared x, and again my pen's not writing well, is equal to 1 minus cosine squared x. You see that? Okay. So instead of cosine squared x here, we can write 1 minus cosine, I have to write slowly because the pen is messing up, divided by sine squared x. Make sense?
Yes, sir.
Okay. Now, since you got the binomial in the numerator and a monomial in the denominator, you can split these. And you can write that as 1 over sine squared x minus cosine x over, now I'm going to be tricky here and write it as sine x times sine x. That's what sine squared is, right? Yay or nay?
Yeah.
Okay. All I did was rewrite it. So this is what? You know what 1 over sine squared is? Another identity. This is a reciprocal identity.
So this one would be sine x squared x over 1?
Okay, no, the reciprocal of that would be cosecant. The reciprocal of sine is cosecant squared x. Okay? Minus. Now, the reason I wrote these this way, split this into cosine x over sine x times 1 over sine x. Right? What's cosine over sine? You know that one?
Cosine over sine.
This is what they call a quotient identity or a ratio identity. This is cotangent x. Right? And then what is 1 over sine again? We just did it.
That's
Cosecant. No, not sine. See, this sine isn't squared. That's just cosecant x. So there we have done. We started out with a fractional form that we couldn't really do much with, and we wound up with something with no fractions whatsoever. Now, yeah, they're a little more complicated, but there's no denominators. So that does make it an easier expression. Okay? Now, they didn't quite do it that way. They just left, they right here did the 1 over sine squared as cosecant squared x, and they just left the 1 minus cosine x alone. And that's fine too. I thought they were going to take it as far as they could, but both of those are correct answers. Well, you can see that. You can, well, not extremely easy to see, but if you multiplied this through, that would give cosine squared x, cosecant squared x, that certainly works. Then you get cosecant squared times cosine. You can then work that out to find that's the same as cosecant times cotangent. So, there's several ways to write the answers. Now that's one example of why I don't use WebAssign. Because WebAssign, if they were looking for this answer, they would tell you that one's wrong. And there's nothing wrong with that answer. Okay? So that's one reason I don't. I just carried it further than they did. But anyway, either one of those is correct answers. All right. And on test, I can figure those things out. Okay. So that was example No, that was the top half of page 358. Let's do example 5 on the bottom half of 358. So I'm going to delete this. All right to delete it? Okay. If I can get my cursor to move. Okay, things are getting squirrely again. We did this yesterday. Okay. All right. This example, example 5 on the bottom half of 358, is also, you can see larsonprecalculus.com for an interactive version of this type of example. So if you don't get satisfied here, go there. Even if you do, you might want to go there. So anyway, here we have secant x plus tangent x is equal to cosine x over 1 minus sine x. Okay. Now, I always put a question mark there because what we're trying to do is verify and see if this is indeed true. Now, there's nothing looking at that that indicates to me there's any truth in that. They don't look at all related to each other. But let's take it one bite at a time. Now, if you didn't listen to the YouTube video yet, you may not know this. Okay, you can work with both sides of the equation at the same time. Just do not cross the equal sign. This is not like solving an equation. They call them a conditional equation. This is verifying an identity. So do not cross the equal sign. Don't multiply both sides by 1 minus sine. No, no. That's crossing the equal sign. You can work with the left-hand side. You can work with the right-hand side. You can do them both at once, separately, whatever. So here is one of my suggestions. And it may or may not be appropriate here, but I'm going to make it. Because these look totally unrelated to each other, I want to do what we just did to this denominator, which was what? Multiplying by its conjugate. Okay, so that's what we're going to do to the right-hand side. Now that's going to give us things in terms of sines and cosines, hopefully. Why don't we do on the left-hand side, get everything there in terms of sines and cosines, and see what it turns out being. So what is secant in terms of sines and cosine? One over
tangent.
No.
Cosine.
Cosine. 1 over cosine. You're absolutely right. Okay. Plus, and what is tangent x in terms of sines and cosine? Just did. Okay. It's the reciprocal of cotangent, which is sine x over cosine x. Okay. Now, time out for a commercial break here. Those trigonometric identities are so incredibly important. Okay, incredibly important. I would get to know them. I am not a big fan of Saturday Night Live. The old version of it was pretty funny. The more recent versions, I don't even know. I don't stay up long enough to watch it. But there was a time, and this was wasn't a fan back then either, but we happened to see it one time, and a guy named John Lovett or something like this had this really lame routine that he would talk. He was sort of like a Rodney Dangerfield, but I don't think you know who he was either, do you?
It sounds familiar.
Yeah, he was always, woe is me type person, and that was his comedy sketch. Oh, poor me, that type of stuff. So his always ended. He talked about how no one paid him attention, and then he'd just start yelling, "Get to know me! Get to know me!" And it was lame. It was really a lame comedy sketch, but he did it. Okay. Well, I say the same thing about the trig identities. get to know them, okay? Get to know them. They are so handy and valuable. You're going to use them repeatedly, especially in this course. If you go any higher, you're going to keep using them always. So anyway, get to know them. So the question is this anything like the right-hand side? Well, let's see. What did you say we might ought to do here?
What's the conjugate?
Multiply by the conjugate. And what is the conjugate of 1 minus sine x?
Cosecant x.
No. The conjugate of 1 minus sine x.
1 plus
1 plus sine
sine x.
x. The reciprocal is secant x. You're right. But the conjugate is 1 plus sine x. Okay?
So
But if you multiply... Huh?
I crossed my knowledge.
Yeah. If you multiply by the denominator, you got to also multiply it by the numerator too, right? And the reason for that is you're only multiplying by 1. You can do that anytime you want to. Okay. Now, what does that yield you here? Don't keep the numerator factor. That's going to be cosine x times 1 plus sine x. Right?
Right.
What does that denominator become?
It becomes 1 sine x squared. Sine squared x.
1 minus sine squared x. You can say it either way you want to. The reason I say it's sine squared x, if I say sine x squared, I have to make sure I've got a parenthesis around that. And it's not sine of x squared, because that could be confusing. So that's why I say sine squared x. Okay, can you tell me what 1 minus sine squared x is? There's that giveaway square of a trig function. What should you think? What kind of identity? Starts with a P. Think right triangle. Somebody's theorem. That's it. The Pythagorean identity then. Whoa, I just had a bird flying to the window here. A little sparrow. And he's not moving much, so I think he must have injured himself. Sorry. All right. Sorry about that. And what would be 1 minus sine squared? We did sort of the reverse of it a little earlier.
Is this the reciprocal?
Not reciprocal. The Pythagorean identity, sine squared x, ring a bell, plus cosine squared x is always equal to 1. Get to know that. Sine squared x plus cosine squared is always equal to 1. But this time we're going to subtract what?
This time we're going to subtract the sine x.
Sine squared x from both sides. Okay. Why? We want it to the right-hand side to look like this, and that'll make it. Here that goes away, so what is 1 minus sine squared x?
It cancels it out.
These cancel out, but this is still left there.
Right. So then it's cos squared or cosine
That's
squared
it.
x.
Okay.
Minus.
Now this time I'm going to split that cosine squared x to cosine x times cosine x. Do you see any reason I might do that?
So then we can
cancel out one of those cosines. Now, let's go back to the left-hand side. We have a common denominator here, don't we? That is cosine x. That what does that leave our numerators being?
1 plus sine of x.
X, exactly. And guess what? This is equal to that. Without crossing the equal sign, we've got the two sides of the equation equal to each other. We just verified the identity. Okay? Now, I'm sure the book didn't do it that way, okay? They like to do just one side at a time and try to make that side equal the other side. And it took them 1, 2, 3, 4, 5 steps to do so. We basically did it in 3, okay? If you work with both sides and bring them down and try to get them to look like each other, okay? Got it?
Got it.
All right. Now, there's a checkpoint at the bottom of that page. That checkpoint, as all the checkpoints are also worked out audio-video solutions at larsonprecalculus.com. So you can see both the example and the checkpoint if you go there. So I would work on those just to get to know them, okay, and how to handle it. Ready for example 6?
Think so.
Okay. Let me erase this one and go on to example 6. So, surprised nobody else is showing up, but
yeah, usually people are here by now.
yeah, it's about the time they're usually getting in, but they should be at home already. Okay. So, up till now, the book has said you ought to work on one side at a time. Now they're saying, let's work with each side separately, which is what we've been doing. So here's another one. Cotangent squared. Oh, they've gone from x to theta. It doesn't matter what the variable is. It's sort of like just a dummy thing anyway, not meaning to disparage thetas at all, over 1 plus cosecant theta. Is that equal to, 1 minus sine theta over sine theta? Okay. Now, I can't believe this is the one they say you should work with both sides. This one would be really so easy just to do the left-hand side. Do a little bit to the right, but not very much. Okay? What do you think you could do to the left-hand side to possibly simplify that a little bit?
We have to find a way to change the cotangent and cosecant.
Okay. Now, that is not a bad idea at all. I was thinking something else, but that will work pretty well. You want it because, and I know the reason you said that, you saw the square up there. And when you saw the square, you thought Pythagorean identity, didn't you?
Yes, sir.
Yes, I figured that was the case. Okay. So let's go back to our Pythagorean identity. I'm so glad you chose this way to do it. All right. What was that basic Pythagorean identity?
Is it tangent?
No.
Oh, no. It's sin squared x plus cos.
Okay, let's use thetas now. Okay. Plus cosine squared theta is equal to what? 1. Excellent. Let me change my theta and make it look more like a theta and less like a wagon wheel. Okay. It started out being an x, and now I put a theta on top of it. Okay, there it is. Now, you're trying to get it to a cotangent squared. You remember what cotangent is in terms of sines and cosines. It's one of those quotient identities or ratio identities. Cotangent is cosine over sine.
Cosine over sine.
So the cotangent squared would be, well, my pen disappeared. Let me get my pen back. Oh, there it is. All right. divide this by sine squared x, sine squared theta. Okay? That will give you your cotangent squared theta. But if you divide that, you have to divide this too, sine squared theta, and divide this by sine squared theta. We got to be nice and democratic about everything, don't we? You know, you do the same thing to both sides of the equation. Every term on both sides of the equation. Now, tell me what sine squared over sine squared is.
That should cancel out, shouldn't it?
It becomes 1. You're absolutely right. Okay. Now, we already determined what cosine over sine is. What's that?
Cosine over sine.
That's why we were just doing it.
It's cotangent.
Yeah, it's cotangent squared theta because they're squared. Okay. And what is 1 over sine squared theta? Well, that's one of those reciprocals.
Okay, so it should be sine, no, cosecant.
Cosecant, you got it. Cosecant squared theta. I have to write so slowly because the pen will screw up if I don't. All right, things are beginning to shape up. If we can just get rid of this 1, well, let's do it by subtracting 1 from both sides. Is that okay?
All right.
Okay. Now I'm running out of room, so I think I'll come down to the bottom here. These 1s have gone away, and you have cotangent squared theta is equal to cosecant squared theta my pen has gone away again. It just shows up every now and then and shows up poorly when it does. Now the eraser's not working well. This is what it started doing yesterday. Okay, that's cosecant squared theta minus 1. All right. Now, we're going to do something backwards now. This is now a difference of 2 perfect squares, right?
Right.
So how can you write that? How can you factor that?
Cosecant squared theta cosecant squared theta minus 1, and then cosecant squared theta
Not
minus,
squared.
Plus 1.
Okay, not squared. Cosecant theta minus 1 times cosecant theta. Yeah, got it. Okay. Exactly. Well, maybe I should do it one step at a time. Let's first write this one as cosecant, I'm having to write so slowly, squared theta minus 1, because that's what cotangent squared is, over 1 plus cosecant theta. Okay. Now, all right. And you've got what that is. This is cosecant theta minus 1 times cosecant theta plus 1. Right? That's what you said. Right?
Right.
I understood you right. All right. So I'm going to erase this. This is what that numerator is. I'm running out of room, so I'm going to erase this down here.
All right.
And probably this too, so I can write that in my numerator. I'll probably come back and erase that too, but I want to make sure I write it right. This is cosecant theta, my pen is doing so strangely, minus 1 times cosecant theta plus 1. Okay. Over 1 plus cosecant theta, right? Now I'm going to erase these here so they don't get in the way. Is that okay?
All right.
Now, what do you notice we have happening here? Because addition is commutative, these two are exactly the same, aren't they?
Right.
And they divide out and become 1. Okay?
Okay.
Now, so that leaves the left-hand side to be cosecant theta minus 1. And that's all. That's all, folks. Okay? So let's work a little bit with the right-hand side. I want to split that numerator over the common denominator, and that would be 1 over sine theta. Agreed? Agreed? Minus sine theta over sine theta, which is sine theta over sine theta. 7 over 7. 45 over 45. 3 over 3. 2 over 2. Anything over itself?
Sine over 1.
No, just 1. Sine theta over sine theta is 1, right?
Oh, that's right.
Yeah. Anything over itself is 1.
Okay.
Okay, you see what I've done there? All right, now let's go back to this cosecant. What is cosecant in terms? There's something wrong with this picture, and I haven't figured out what it is yet. Well, let's keep trucking. It doesn't look like it's working well, but let's see if it does. Yeah, I think it'll work out. What is cosecant theta? Reciprocal identity.
Cosecant theta, the reciprocal identity of it should be sine theta.
1 over sine.
1 over sine.
Yeah, because sine and cosecant are reciprocal of each other. Minus 1. Right?
Right.
Yep, that works out perfectly. I was afraid the signs were wrong, but they were not. The SIG inside. We got the same thing on both sides. We only had to do a little bit on the right-hand side. Left-hand side wasn't much worse. Okay? 1 over sine squared minus 1. Both sides, they're the same. So sure enough, rather than being a question mark, that is a definite equal sign. Now, it says my internet connection is unstable. I do not know why that said that. I don't know if you saw that on the screen or not, but that's over with. Okay. Now, I can't believe it. I don't know. You said you didn't have your book there in front of you. But if you're looking on page 359, example 6 at the top of that page, they wind up with exactly the, oh no, I see, I'm sorry. They do it slightly differently. They almost always do, but they come up with that it is an identity. And there is a checkpoint too, so please do the checkpoints. Even though this example wasn't at larsonprecalculus.com, the checkpoint is, so please do those. So let's move on to example 7. Now, I've lost your picture. Are you still there?
Yeah, I'm still
okay,
here.
Good. All right, that's okay. I don't have to see you, but I just wondered if anything had changed. So I'm going to erase this. If you got it all, do you?
Yes.
Okay. So I'll erase this, and we'll go on to do example 7. And this shows the powers of trigonometric functions rewritten as more complicated sums of products of trigonometric functions, a common procedure used in calculus. Okay, so this one, they make it sound like it's really hairy, it really isn't. This is a pretty simple example. Here we have a tangent to the fourth power, they've gone back to x now, being the dummy variable, is equal to tangent squared x times secant squared x. If the pen would write, it's quit writing. Okay, secant squared x minus tangent squared x. I don't know why it's not writing squared x. I just have to slow way down. Okay. This is what they're asking. Is that indeed an identity? The pen is just not wanting to write. There it goes. I wrote twice there. Okay. What would you do to try to verify that?
Probably simplify it a little bit.
Which side?
Let's start with the left side.
Okay. I'm sort of okay with the left side, because the right side has way more terms in it, and the left side is all tangents, even though it's raised to the fourth power. But let's leave that alone. Let's see if we can simplify the right-hand side a little bit. What's the first thing that strikes you as a possibility for simplifying? Go back, put on your algebra hat. Not just the trig hat, the algebra hat too.
Subtracting from both sides?
Okay, no. Remember, you can't do anything to both sides. You can't cross that equal sign.
Right.
It's got a question mark over it. That's why you can't do that. Okay. The right-hand side, that's a two-term expression, right?
We can factor out.
Oh, yes. Let's do that. What can you factor out?
We can factor out tangent squared
X. And what does that leave you with?
It should leave you with secant, or 1.
Okay, wait a minute. You're right. Secant
squared of
x minus 1. Perfect. Now, what does that remind you of?
The reciprocal.
Not reciprocal.
No, the identity.
Which one?
Is it cosine over sine?
Okay. No, now tangent is sine over cosine. Let's leave that alone for now. We got tangents on the other side too. I'm talking about secant squared minus 1. Anytime you see a square of a trig function, especially if 1's involved with it somehow, what identities does that lead you to? The P ones? The P ones? Right triangle?
Oh,
Pythagorean identity. You want to go back to the original, or do you know the one that this relates to?
I don't know the one.
Let's go back to the original. What is that again?
It's the sine squared x.
Right.
Equals cosine.
Plus cosine squared x.
Plus cosine squared x
equals 1. That's it. Get to know that. Okay?
Yes,
now, at this point, we want somehow to get a secant squared out of all that. And you remember what secant is in terms of either sine or cosine. And that's going to be a reciprocal one. What is secant in terms of either sine or cosine? Okay. Sine matches up with cosecant. Tangent matches up with cotangent as far as reciprocals. So what would secant match up with?
With cosine?
Cosine. 1 over cosine is secant. So if we divide everything by a cosine squared x here, that's going to wind up being a secant squared. But we can't just do it there. We must do it here, cosine squared x, and we must do it here, cosine squared x. Okay. Now,
so we can cancel out the cosine of x.
Well, that's going to become a 1. Okay, you don't just cancel out. That divides out to be a 1. Just like 1 plus sine x over 1 plus sine x, that's 1. 7 over 7, that's 1. Anything over itself is 1. Okay, except 0. 0 over 0 is not defined. Okay. Anything else over itself is 1. So that's going to be a 1. That's not a cancellation, that's a 1. Okay, and we know what this is. That's why we started it. 1 over cosine squared is? That's why we did it.
It's
Secant squared. That's secant squared. Okay, and that's a 1. Okay, and what's sine squared over cosine squared? Sine over cosine. One of those. That's one of. Say again? You may have said it. You may have said it. I couldn't hear.
Oh, I was saying sine over cosine.
Is what?
It's 1.
No. Cosine over cosine is 1. Sine over cosine is tangent. So this will be a tangent squared x. Okay? So instead of this, we'll write that. So what do we have there? We have tangent squared x plus 1 equal secant squared x. Right? Okay. Here we have secant squared x minus 1. So if we can subtract a 1 here and a 1 there, we're going to have exactly, what's that?
Then it'll be equal to the same
tangent squared x. So this is equal to tangent squared x that you already had there times another tangent squared x that you get from this one. And guess what tangent squared times tangent squared is?
tangent to the 4th power.
Absolutely, and that's what you've got on the left hand side. You see? So that makes that equality true. You see it? It's sort of fun, aren't they? Once you kind of get the hang of them. Okay? That was the A part. Let's do the B part. Do you need this up there any longer? Yay or nay? You still there?
Yes, I'm still
Okay.
here.
Do you need that up here any longer?
Oh, no, sir. I think I got it.
Okay. All right. I didn't want to erase it if you were still writing. Well, I can't get it. My cursor is doing just whatever it wants to. Okay. Nope, that's not the one I wanted to do. I want to do that one. Okay. So let's do, get my pen back. Get my pen back. Okay, there we go. All right, the B part. Cosecant to the 4th. No, they're still using x times cotangent x. They're claiming that's equal to cosecant squared x. Excuse me, times cotangent x plus cotangent cubed x. It's a pretty ugly 3, isn't it? Okay. Now, where would you begin here?
side the last time. Let's say the right side this time.
I think that's a good idea because that's a little more complicated. If possible, start with the most complicated side because you're trying to simplify it. Now,
Okay.
what is one possible thing you can do to simplify that?
It looks like it's already been simplified for us.
Well, the part of it has. The cosecant squared is pulled out. That's good. But then, in that parenthetical expression there, what can you do?
We can factor it out as well.
Oh, yes. Let's see. The cosecant squared, we're going to leave that alone for now. In fact, we may leave it alone, period, because you got something like that on the other side. Okay? And then here, we're going to pull out a what? Factor out a cotangent x. And that's going to leave us with what?
With cotangent squared.
No, you got a 1 here. You see? When you divide out, you don't throw it away. Yeah,
cotangent
1 plus cotangent squared x. That's one reason a lot of mathematicians kind of hate the word canceling, because you think you get rid of it. You don't. You're dividing it out, and when you divide a cotangent by cotangent, you get 1. Remember that. Okay. Now, that's a squared x, not a 2x. My pen wasn't writing well, and I was trying to make it write better, and it was giving me problems, so I wrote too big. It's still giving me problems and erasing things I've just written. I don't know what's wrong with the pen. There. That looks a little more like a square. Okay. Now, when you look at something like that last parenthetical expression, 1 plus cotangent squared x, what should come to mind? What kind of identity?
The Pythagorean.
Yes, yes, yes. Now, do you know the one that deals with ones and cotangent squared, or do you want to go back to the original?
I say let's go back to the original.
Okay, I think that's a good idea. And what is it?
It's sine squared of x.
Right.
Plus cosine squared x.
What about
equals
it?
1.
Equals 1. You got it. Now, you got to come up with a cotangent squared out of that. Now, do you remember what cotangent is in terms of sines and cosines?
Cotangent should be, isn't it sine over cosine?
No, that's tangent.
Or that was tangent.
Right.
So then should this one be cosine over sine?
Excellent. So if you were to divide this thing, the cosine, by sine, of course, squared x, that's going to give you a cotangent squared x. But if you divide that by sine squared, you better divide this by sine squared, right?
Right.
And this by sine squared. And my pen still decides just to quit writing whenever it wants to. Okay, there we go. Now, what does that first term give you?
Cotangent x.
Okay, wait. First term. Sine squared over sine squared.
Yeah, so those two will equal 1.
1. You got it. So this is a 1 plus, and what was cosine over sine?
Cosine over sine. That one was cotangent.
Cotangent. So this is cotangent squared, right? Can you read it up there? I'm writing in the red, but...
Oh, yeah, I can see it though.
Okay, yeah. Okay. Is equal to, and what's 1 over sine squared?
1 over sine squared.
Or 1 over sine? cosecant. So this would be cosecant. If it would write, it's not writing. There, cosecant squared x. Now, I wrote on top of it and then it didn't. This is so frustrating. Okay, that's really ugly. Okay, that looks a little bit better. I swear. All right, got my pen back. All right, so now we got what 1 plus cotangent squared is. That is cosecant squared, isn't it? Isn't that what the identity just told us? So let's write this as cosecant squared x, right? And what does that give you? Cosecant squared times cosecant squared is?
Oh, it's cosecant to the fourth.
Cosecant to the fourth power of x times cotangent x, right?
And that's the same.
And that's the same thing as the left-hand side. Check. It works. Does that make sense?
Yes, sir.
Speaking of checks, there's a checkpoint after example 7. So please try to do that as soon as you can after class. Now there is a summary at the bottom of page 359. It's just one little thing there, okay? But then let's go to the vocabulary in 5.2. An equation that is true for all real values in the domain of a variable is an blank. You don't have your book with you, do you?
No, sir.
Okay. If you go back to the very first page in the section, which is page 355, you'll see just about the middle of the page, just a little above the middle of the page, it says, on the other hand, which you don't know what the first hand was, an equation that is true for all real values in the domain of the variable is an identity. That's what we've been doing, verifying identities, trigonometric identities. So that's number 1. Number 2, an equation that is true for only some values in the domain of an equation is a blank blank. No. That's, again, on that first page of the section, 355, it says, remember that a conditional equation is an equation that is true for only some values in the domain. In other words, when you're trying to solve an equation, it only works for certain values, okay? So that's called a conditional equation. If it works for all values, like these have been doing, those are identities. Okay, that was the distinction it's trying to make. Now, we've seen some of these before. You will see them again. So let's review them. Number 3, 1 over cotangent u is? What's the reciprocal?
1 over cotangent
yeah.
is cosine over sine.
Well, cotangent is cosine over sine. 1 over that would then be sine over cosine. And what's that?
Sine over cosine, and that's tangent.
Tangent, yes. 1 over cotangent is tangent. You got it. That's the reciprocal identity. What you did was using the quotient or ratio identity, you got to the same answer. Okay? Number 4, cosine u over sine u is?
Sine over sine is
cotangent u. Perfect. Number 5 is a little bit different kind of identity. We don't really use that much, but it's true. Cosine of pi halves minus u. Well, this,
I don't know that one.
okay. Pi halves minus u, if you think back, boy, section 4.1 or 4.2, somewhere back there, way back at the very beginning, we said that any two angles that add to be 90 degrees are called, wow, your hair is pretty today. That was supposed to be a compliment. Complimentary. I was just kidding, of course. Okay.
Oh, I was like really confused. I was like, what?
Yeah. No. Okay. So that's the complement of u. Pi halves minus u is the complement of u. And the cosine of a complement of u would be the sine of u. The co means complement of. So if you take the complement of a complement, you get back to the thing, and that would be a sine. Cosine of the complement of u is sine u. Okay? Any of the co-functions or functions going to co-functions, that's what you do with it. Okay, number 6. 1 plus blank is equal to cosecant squared u.
1 plus sine?
No, cosecant squared, not cosine squared. It's cosecant squared. 1 plus, and it was, I think, the one that's on the board right now, isn't it?
It's 1 plus sine, isn't it?
No, look on the board right now, up in the red.
The red. Oh, cotangent.
1 plus cotangent x is cosecant, cotangent squared x is cosecant squared x. That's exactly what we got here. 1 plus cotangent squared u is cosecant squared u. You see it? Oh, you don't see the book. Okay. Now.
Well, I mean, I see it up on the.
Yeah, right.
In the red.
Okay, so that would have been the right thing to fill in there, cotangent squared x. Number 7. Cosecant of negative u is what?
It's sine?
No, it's related to sine because sine is an odd function, so is cosecant. So that would be cosecant of negative u would be the negative of cosecant u because it's an odd function. That again was one of those, and again, go back to that it was in 5.1, the beginning of 5.1, that table of your
yeah, I'll go
identities. And
I'll
that
go back and look into that.
Oh, you got it. Yeah, the even and odd identities at the very bottom of that block, fundamental trigonometric identities. Okay, and here's another, number 8. Secant of negative u is equal to it's secant u. That's an even function because cosine is even. Of your trig functions, sine is odd, cosine's even, but tangent's odd. And then the reciprocal functions are the same as the others. Cosecant would be odd, secant would be even, and cotangent would be odd. So only 2 of them are even. That's cosine and secant. The other 4 are odd. All right, homework exercises then would include any of the odds 9 through 17. They're all at Calc Chat. 9's at Calc View. Any of the odds 19 to 23, they're all at Calc Chat. 21's at Calc View. Any of the odds 25 to 29, they're all at Calc Chat. 27's at Calc View. Any of the odds 31 to 35, they're all at Calc Chat. 33's at Calc View. Any of the odds 37 to 41, they're all at Calc Chat. 41's at Calc View. And then you can do 43. That's one of those I really don't care for too much because they write down something that's wrong and you figure out where the error is. I hate for the book to write anything that's wrong because you may remember that and not remember what's right. But that's another issue. So anyway, for any of the odds 45 to 49, they're all at Calc Chat. 51 or 53, they're both at Calc Chat. 51's at Calc View. 55's at Calc Chat. 57 or 59 are at Calc Chat. 57's at Calc View. 61 is a rate of change. It should be at Calc Chat. 63 is a true fault. 63 and 65 are true false. They should be at Calc Chat. You can think about doing 67 or 69. They're both at Calc Chat as well. All right. So we're through with 5.2. Any questions on 5.2?
I don't think so.
Okay. Work on those, especially focusing on those trig identities. That will be most helpful. We, I think, are 3 minutes over. Is that right?
Yes, sir.
4 minutes now. And sorry, but there'll be no extra charge, so you skated by that one, okay? We'll begin 5.3 next time. But then the sad news, you realize, is next time is not until more than a week away. Because next week, sadly, is spring break week, and there are no classes. I will not be signing on to Zoom or anything else next week. So next week is free. The following week, I think it's Tuesday the 31st, we'll be back for same time, same station, right?
Okay.
It won't be the same code because every time I open one of these, it'll have a different code. And if I can get the 112 students off the air in time, then I'll get the code out there as soon as I can. Okay?
Alrighty.
All right. Well, then have a good spring break. Be safe. Be careful. Try to stay isolated as much as possible within your family, of course. But don't get around crowds. It's just not safe right now.
I think that our goal is to just stay at home for spring
Yeah.
break, have like a staycation.
I think that's a great idea. We've been out of the house in the yard, but that's all. My wife took the dog on a walk, but she didn't get around any person yesterday. And I can't do it today, but tomorrow we'll be going on a walk together. But we're going to stay away from people. We're going to stay at home.
We've been doing a lot of yard work too.
Yeah, and
Just as a way to keep busy.
that's exactly what I think I've got on schedule for tomorrow afternoon and possibly Saturday. Now, we may go over to Georgia, which I know doesn't sound like a good idea, but you see, in Georgia, we're on a farm that's 8 miles from the closest flashing light, 10 miles from the closest red, yellow, green stoplight. So we're out in the boonies. We would be in great shape there as far as being isolated. The trouble is we have to drive through places to get there. Of course, in the car we're okay, but when we stop to get gas or use the restroom and stuff like that, that's where the problems would come. And Karen's all equipped with wipes and everything else. So if we go, we're going to be washing hands a lot. So
Did you
getting
make sure
there.
you're stuck up on toilet paper?
Yeah, we got plenty. Yeah, we always buy it when it's on sale, so we always have plenty. So anyway, yeah, we haven't decided for sure if we're going to go. We're going to call over and make sure everybody's well there. I have 2 brothers and a sister that also live on the farm, but none of them are within sight of the house, but they're close enough they can visit. But we were going to tell them, if they come over, we have to visit outside and stay 6 feet apart. We're not, unfortunately, they can't come into our house, because they could be bringing whoever they were in contact with in. So we've got
to be careful with my Nana.
What's that?
We've got to be careful with my Nana because she's older.
Exactly.
She has like a lot of heart medicine and stuff, and we don't want to get her involved in this stuff.
Right, exactly. And that's exactly the deal. My sister-in-law is keeping 2 of her grandchildren because both of their parents are doctors and they have to be on call because of this. So she's keeping them. But they were with the other grandparents, and then the grandmother got sick, and they're not sure what hers is. So they're not going to let the kids come over unless we stay outside, but then we're not touching the kids. Even though we want to hug them, we can't do it. We're going to just be out in the yard with them, but not having any contact with them. So it's weird. It's so strange, but we're going to do what we can.
Yeah.
All right. Well,
you stay safe, Mr. Fowler.
All right. Thank you so much, and you do too. We'll see you in a week and a half then.
All righty.
Tuesday morning. Bye-bye.